stats to remind myself. So show you guys that I do know how to spell. Not how you spell limit. I understand that. See if you can figure out why I spelled it that way. Goodness gracious! Just ruined it for everyone. So like 1 second.
That was a Gavin moment.
So I used to like when I was teaching, like not from this book, I would always write it like that. So I write it with limits, but the idea is, when I ask you to find like the limit as x approaches 2 of like x to the third, this is your x value, and what you get would be 2 to the third, which is 8, and that's your y value. So limits are just y values. Often they're just plug it in and give it to you, and that's the y value. But what we're looking at here is removable discontinuities, where I've got a hole, and the question is going to say something like, if this function is going to be continuous, what's the y value that I need to make that happen, or to plug in that hole? So basically, our job is to put a dot. I don't remember who built this bridge, but like someone built 2 roads, and I think it was Elena maybe, and like walked away and didn't build a bridge. It's gonna be our job to build the bridge that's like in the wrong spot.
Yeah. I was like that.
You did this. You did like build the bridge, so you just did. So we got a bit 2 roads built, but I got to figure out where to build the bridge. That's basically what these questions are. What is going to be the y value of the bridge so I can close that hole and make it so that everything is continuous? So remember that limits are y values. So when I ask you how to find the y value, that's essentially find the limit. So removable discontinuity is where this is, I'm just going to, it's up there, I don't know if this is stupid, I'm writing it again. But the limit exists and the bridge exists, but they're in different spots. You get a situation like this. And that's a removable discontinuity because we can remove it by just reassigning where that bridge goes. Apparently, we can like pick up bridges, walk a little bit, and put it back down. That's cool. I mean, I'm pretty strong. I don't know if you guys have ever seen that. You might not be able to do it, but I can. So, if I'm looking at number 1, first issue is like, where is there a discontinuity? So, usually I think in every one of these, I don't think like the ln or the negative square roots come into play. I think it's all just like, where's the bottom equals 0 or a piece of x, yeah. So, there's 3 ways we get discontinuity, but the main one is 0 is the bottom. So, I'm going to set the bottom equal to 0, and that would give me x equals 1. And remember, 2 ways to think about this. That is where I got the x equals 1 from. And if that forces a cancel to happen, that's a removable discontinuity. Or, if you plug this back into the top and you get 0, then you get 0 over 0, and that's a removable discontinuity. So there is a removable discontinuity at x equals 1 because of either of those reasons that you factor that led to equals 1 cancels, or when you plug 1 in, you get 0. So that's kind of the x value. Now, how do you find the y value? So normally if I want to find y values, if I give you like y equals 3x squared, say x equals 1, find the y value, what do you do with the 1? Plug it in for x. Well, if I plug 1 in for x there, what's going to happen? I'm going to get this 0 over 0, right? How else can I find y values? How else can I find y values? So let's just find the limit. The limit is a y value. So I want to find, this question turns into the limit as x approaches what? What is x going to approach? 1, because that's where the discontinuity was, of x squared minus 1 over x minus 1. So we'll get limit as x approaches 1 of x plus 1, x minus 1 over x minus 1, cancel, cancel. I can plug 1 in there, and that's 2. So the x value comes from where does the bottom equal 0, or later on we'll get like these jump discontinuities. I'll go through a couple of those. And then the y value comes from the limit at that x value. Is that right for 1? Yeah.
So basically, when you can't find it, just find the limit of it.
You can't find the y value, you use the limit to 2. Is that what you're asking? Yeah. Alright, let's look at 2. If the function is continuous for all real numbers, so what they're saying is there are no discontinuities here. And if this is true when x is not equal to 4, then negative 4 equals this. So let me show you how this would also be written. So they're writing out in words, but this is essentially the same thing as this. This is what's true when x is not equal to negative 4. And they're saying find what would go here when x does equal negative 4 to make it so the function is continuous everywhere. So there's no holes, there's no gaps, there's nothing. So if I just look at this piece, this has a discontinuity. Where does this have a discontinuity? At negative 4, and that's because the bottom would equal 0 there, right? So that's got a discontinuity at x equals negative 4. But the question says it's continuous everywhere. So right now we've got this kind of situation. Where this x value is negative 4. And if it is continuous everywhere, then I know that dot must have been filled in. The x value of that dot is negative 4. My question is, what's the y value of that dot? How do I find y values? Limits. So my job is to find the limit as x approaches what? Negative 4, because that's the discontinuity of that function. I'm just going to factor it like as I'm writing it. Is that okay? You guys see what I'm doing there? And then those will cancel. If I plug negative 4 into that x plus 2, can you see this? So I have filled in this is this dot. Basically just filling in that hole. Question on 2 there? Is this the one where that's an 8 in your book?
There's no 8.
There's just a 1.
Just a 1.
So that should be 18. So if you haven't watched the notes yet, they fixed it in the notes, right?
Yeah.
But if you haven't watched the notes yet, it doesn't work if that's just a 1. You can't factor it. So make that an 18, like write that 8 there. But don't do it now, because if you do it now, I'll know you didn't watch the video, so you should like sneak it in like a few minutes.
They did the same thing in that test run.
This is a 21 one.
Yeah, it was just a 2.
Yeah, I saw that. It's like one of the
Yeah.
little ones. Yeah.
Yeah.
Remind me to like point that out after this. Thank you.
No.
Okay.
21.
So this is the same thing. They're telling me it's continuous. So there can't be any holes, there can't be any issues. Well, I've got this x equals negative 6, x equals 6. So this means, sorry, 6. That means I've got one situation for the entire graph, except when x equals 6. And then I've got another situation. I've got a y value when x equals 6. And that y value does fill in the dot. How do I know it fills in the dot? It says it's continuous. So if it's continuous, it must have filled in the dot. I know the x value of the dot is 6. My job is to find the y value of the dot. Well, how do I find y values? Limits, right? So the question is essentially this. What's the limit as x approaches 6 of x squared minus 3x minus 18 over x minus 6? So I can factor. What's the 8 is there? Makes 18, you can factor. X sixes will go away. Now you can plug 6 in. 6 plus 3 is 9. And so A would have to equal 9. So if I make that a 9, that would be the spot that fills in that dot. And it makes it everywhere. No holes, no gaps. Where are they? So I think they're all fairly similar to that. If they're not, we'll figure it out and go from there. And I'll go through a couple more, whatever I need. But at 13, on in your workbook, I don't think that says 21. I think it says 2. So that in your workbook needs to be corrected because it won't factor otherwise. That's a 21. Number 13. Keep working on it. Always encourage you to check your answers as you're going. You know, let me know. But I don't think there's different type in there, but something. Finish your early section and notes.
I did a lot of practice of skewing in this class, so I think that I'm going to call it a win and say I was wrong.
Two multiple choice were not those. Just you heard me.
Thank God I practiced. That's awesome. The one multiple choice one I got wrong was the second football player one. Correct.
Middle 75%.
Yeah, because I was talking to Matthew, and I figured out what I did. I was just thinking about it. I took 75, divided it by 2, and then normal CDF, and I realized that I didn't. What I did was instead of having the middle 20, the outside 25%, I excluded the middle 25%.
You did the 2 houses.
Yeah.
Oh, really?
So what I ended up doing was taking out the middle 25%.
The other one you missed is phone number is not quantitative. Because, like, if I said, like, what's the average phone
It's like
number
a
in
zip
this class?
It's like a zip code.
Yeah, like,
Because on the front,
That would be
it
the
was
one I got
like
is
a
it-
zip code.
Yeah.
You should like Connor.
the zip code was in the.
And then the first page of our notes, it said like which ones are like numbers but are.
It saved me. I was,
Yeah.
Well, I thought it. I was like, I'm pretty sure it's not. And then I saw the zip code. I was like,
It's weird the people that don't do the notes that didn't do well.
crazy.
I heard Zach Cornell did this.
he lost his notepad.
Which is just
No card.
His packet.
Why did he tell me I didn't want to pack?
He wasn't gonna do it either way.
That's
but you get X from the other side. Instead of me
Really?
writing like C divided by V equals X, I
No,
know
try
C
to
over.
Okay, they're not
And that
some.
They have one really good
She
girl.
said, "You're doing it wrong." And I said, "What?" And she said, "It's not a fraction."
They are fake
And I
mistakes.
said, "Yes, it is."
See, they're good.
I get, yeah, but
Are you? What do you guys think?
No.
But it's like a, cause it's kind of hard to tell because Dundee, who we like go on the water every year, they beat Detroit Country Day, but then there's other instances of Detroit Country Day beat other people. So it's kind of
Like, where is this money coming from? It's straight.
So it's like, oh, it's gonna be really hard to meet every single time we have a meeting. I'm like, no, it's not. So it's hard. This one's next to Jackson. You're thinking like that. Think like that.
Oh, he does. Yeah, he just says maybe.
You can't go in.
They have the girl. Trenton has the girl that's first in the state, the 5.
Oh, here's the thing.
Yeah, it's beautiful. That's it. And I'm third. So like the difference between first and third is crazy. I know. That's like a whole. That's like a 25 at least. Yeah. I was like, oh my god, the difference between first and third. 1, 5, 60, 531, 530. The 530. Yeah.
That's like games are gonna be best.
Yeah. No, it's like.
I don't remember them having rice trophies. And your kids better than me, so.
$25. Oh, we made that work for sure.
Yeah, mine is no stomach or lunch.
No food this time.
Skew the prices.
This is just the thing.
Kind of. Will you guys think you post this stuff?
No, no, it doesn't make
See, those are just like, $30 like that.
Yeah.
Or some of them were like $7. What would it look like? $30, I can't actually